Okay, welcome back once again. I apologize that we had some technical issue that we needed to charge the camera swivel technology. So now it's actually on charge. So I was talking about the exam. When you click on the exam, you will see a timed quiz message here. Once you click Start Attempt, your quiz will start. Then you'll have 2 hours to complete this quiz. You have to complete the quiz in one session. And which means once you start, you will have 2 hours. Here's a real question from the exam. This is a real question. This is exactly what you're going to see. And of course, you're not going to take a picture of this real exam. So question is a linked list, and also for online students, this is a real question. This is documented, so you don't really have to take a picture. It's already recorded. A linked list is a collection of components called, we have 4 choices here. So if you have been reading the material, you have been following, and you probably pretty much know the answer. It's a really straightforward answer. So that's how the questions will be available to you. So you can see all the questions here, all 100 questions. You can actually skip a question, jump to another question, and you can always come back. Once you are done with answering that question, you can click Next to go to the next question, or you can go to a specific question. I'm going to jump to another question. Here I'm clicking another question here. So this question says, which of the following correctly initializes a doubly linked list in the default constructor? So we talked about briefly the doubly linked list, but if you have been reading the material, you have these 3 or 4 choices here. So it's asking you, how do you initialize a doubly linked list? So you can actually figure that out, that answer as well. Let me see if I can find a question with true false. There might be 1 or 2 questions which are fill in the blanks. A few of them, very, very few of them. So if you see a question which requires you to answer true false, and again, this will allow you to figure it out how to answer those questions. And again, those are like definition questions. So it will ask you the specific definition. Here is a question. And it's a true-false question. So a queue is a first-in, first-out data structure. So we have not discussed queues yet. We'll be discussing in a short while. But you can actually, if you know the material, you can actually answer that question very quickly. From last week, we talked about stacks, what the stacks look like, what the structure is. So it's asking you what kind of data structure is a queue. In fact, we'll be starting our discussion right exactly from this particular question. All right, so once you are done with your question, also just want to highlight the timing here. The timing of your exam shows up here. So I have, let me see if I can show you on the camera. It might not be, yeah, right there. Probably you can see a little bit. So time left is 1 hour and 48 minutes. It shows you the time right there. Okay? Any questions about the exam? No questions about the exam? Okay. An exam will be available to you right here. So next week will be right there. So notice that nothing else is due that week, so you can just focus on the exam. Exam is worth about 100 points, so you want to prepare well and do well in this exam. Okay, I'm going to go ahead and get started on our queues discussion. Let me see if I can run this slideshow. I know camera is going crazy. It's just following me along, so it's just going crazy. So in queues, what kind of data structure was stacks from last week? FIFO. So first in, first out. And according to your book, queues are set of elements of the same type, just like what we discussed last time, added one from one end, the back or the rear, and delete it from the other end, the front. And this one is a FIFO data structure, first in, first out. So it's a first in, first out structure. An example given here is a line, waiting line in a bank. So when you go to the bank, you're waiting in a line to see a teller or see a cashier. So you are the first one in that line. There are people behind you. So which individual will be served first? The individual who is actually right in the front, right? The first individual, first person in the. So in this case, it's actually the FIFO, first in, first out data structure. So first node or first element which is added will be processed first. First in, first out. It will be processed first. So it's a middle elements are inaccessible. So if the individual who is in the middle of the line has to wait before all other elements are processed or all other customers are processed. So that's the concept in queues. Just like our stacks, we have to check if my queue is empty, if my queue is full. I also want to initialize my queue, just like what we did with stack. We wanted to check if my stack is empty, my stack is full, and I want to initialize my stack. So we actually have very similar methods. In fact, the code is also very similar. There are minor differences you will see, especially when it comes to front and back. In this case, we want to check what is the front value, what is the back value. So I want to check that one. And also, especially if it's a circular queue, where you want to ensure that you're able to circle through as well. If it's a straight line, it's much easier. But if it's a circular one, you want to have one or two extra variables to ensure that you're able to process all the nodes. Like we had add stack, here we have add queue, delete queue. And in this particular case, we also add an abstract data type, virtual methods, and those allow us to ensure that the developer implements the definitions of all the methods. So those must be in place. If you don't have an abstract data type, then the developer might not develop them. But if you have an abstract data type, then those will be dictated later on in the derived class. So here, unlike stacks, we need extra variables. So it's saying we need at least 4 variables. One, definitely we need some kind of list, some kind of array to store all the elements, just like what we did in stack as well. We need a front queue front and queue rear. So there's some difference here. So we need to ensure that we have something in the front to track first and last elements, and also the maximum queue size. We had maximum stack size as well, to specify maximum size of the queue. So we want to make sure that we are not overflowing our queue. To add an element to the queue, advance queue rear to next array position. So here we are. This is our first element, which is added here. So then we can move on to the second and the third, and so that's what it's saying, advance queue rear to next. So initially, when you have no data, so both of your variables, queue front and queue rear, are pointing towards the first location or first node or first element. Then you want to advance queue rear to the next one. So this will become your front. This is your first customer. This is the second customer, third customer if you are in the bank queue. So, and then you want to advance the queue rear to figure it out how many elements have been added. Okay, the size of the queue could be larger. Like in this case, it's showing us size is 100. But how many elements are in place, that will be determined by the queue rear. Add element to position pointed by queue rear. So if you are pointing queue rear here, that's where the data will be added. Once the data has been added, then you want to increment your queue rear to the next position. So that's how you can ensure the data has been added in the correct location. Here's an example. Yeah, let me finish my thought and then I'll. Here's an example. So you're still pointing your Q front here to the first element. And let's assume we have added 3 elements, 0, 1, 2. So Q rear is pointing towards this element here. Once this has been added, then you can actually move to the fourth element. Yes, question?
And Q front remains at the beginning element?
That's right. You keep it there. If you remember, we did something similar. We want to make sure that you have something in the beginning so you can figure it out, especially when it comes to the circular one. If it's a circular one, how do you know where you stop? So if it's a straight line, you can say, okay, I'm going to run an entire list. If I end my array size, then I'm going to end. But how do you know if it's a circular one? Otherwise, you'll stay in this forever. And I think we talk about circular queue in this case. To delete an element, something very similar. To delete, let's say I want to delete. Let's say this customer has been processed. This was the first customer. I want to get rid of this customer. So technically, if you just move your queue front to the next position, that can be removed. That's not in the list anymore. And that's exactly what's showing here. Queue front is from 0 to 1. It's incremented to 1 because this particular element has been processed. Retrieve element pointed to by queue front. Advance queue front to the next queue position. Really simple concept. So if I really process that to the next position, I will be in the right place. It shows you an example here. I'm not going to go into this example. I'll just show you some data here. Let A represent adding an element and D represent deleting an element. Consider the following sequence. I'm not going to spend time on this one. It just shows you how to add, and delete and add. So it's not a very good example given in the book. So this would eventually set Q rear to point to the last array position. So notice that here, assuming we have processed all of these here, now our Q front is pointing here, and Q rear is pointing here. So we have the last 3 positions or last 3 elements which need to be processed. So giving the impression that Q is full, what do you think? Is Q full right now? So here we're talking about this would eventually set Q rear to point to the last array position, give you the impression that Q is full. Is Q full? Looks like it's full, but we have all these elements which were processed earlier on, but they are available to us. So assume that you had 100 customers. So 97 of the customers have been processed. This is the 98, 99, and 100th customer. So you still have a lot of these open positions. So if you have a circular queue, then you can go back and start processing in that same order. Instead of adding additional elements, you can actually use those available positions as well. Just so it wants you to think about it. So it provides some solutions. It provides some cases, some scenarios in your book. It says one solution is when queue overflows at rear, especially when Q rear points to the last array position, check the value of Q front. If the Q front is pointing towards the first element, then it is absolutely full. We know it's full because all of the positions have been adjusted. If the Q front indicates here, indicates there is room at front, then slide all array elements toward the first array position. So what he's saying is that if the Q front is not in the 0th element position, 0th index, it means we have some positions available. Those positions can be used. Otherwise, those positions are sitting in the memory without any use. They are not being processed. They are just taking space. So problem in this solution is too slow for large queues when you have very large amount of data. Solution 2 is assume that the array is circular. If array is circular, that will make it more efficient. So that's what the solution is. It wants you to think about these scenarios in this case. So if you have array is circular, so let's say this was 99th or 100th element. This was 99th element, 98th element. So you can continue to add more data if it's needed in a circular array. And then it shows you the example here. And it also shows you the example of deletion. So I'm going to show you my examples later on. And there's multiple ways you can delete the data. Then it shows you the problem. I'm going to show you my own problem, and I'll highlight that one. So for solution one, the solution one which we discussed earlier, keep a count. So we need a variable for counting how many elements we have added, how many elements are being processed. Increment it when new element is added, decrement when the element is deleted, and initially count is 0. And we did something very similar last week as well when we had count variable for stack as well. Very useful if user of queue frequently needs to know the number of elements in the queue. Okay? Because the count is going to tell me how many elements are there. So I don't have to waste time to figure it out. Counter will tell me there are 3 elements, or there are 300 or 3 million elements. And that's the same thing we did in case of stacks as well. Solution 2 is let queue front indicate index of array, which is possible. We can easily find out the index of the array preceding the first element. Queue rear still indicates index of last one. So queue rear tells me the last element which was added in the array. It's telling me queue front can give you the information about where the position queue front is pointing to. So we can figure it out. If we subtract from queue rear to queue front, we can figure it out how many elements are there which are being accommodated at that time. So it's saying queue front equals queue. If we check this one, if they are not equal, circle through the circular queue. If they are not equal. For example, if queue rear is right here and queue front is here, if I check, are they equal? If they're not equal, go and process the next one, process the next one, process the next one. At one stage, they will become equal. So it's providing you another way to access the data. Slot indicated by queue front is reserved. Queue is full if next available space is the reserved slot indicated by queue front, which means that it will be indicating it's full if immediately after queue front is reserved. And it shows you an example here. So this is our queue where data is, and these are processed, these are available. So queue front is 1 right there, and queue rear is 97 right here. So it means I'm right here, so there's some data here, there's some data here. So it looks like this is full because queue front is right there. It is full. But again, if it's a circular one, you can actually move your queue rear to the next element and you can process that one as well. Then it provides you various other ways to delete the data as well. And again, it checks that if the count equals 0, it will tell us it is empty, just like what we did last time. Queue will be full if its count equals to maximum queue size. If the maximum queue size is 100, if the count is 100, then of course it's going to be full. And that same method we use, very similar method we use in stack. So if the count equals 0, it's empty. If the count equals maximum queue size, it's full. There's hardly any change. Hardly any change. The only change is the name is different. Instead of stack type, we are saying queue type. Okay, so very similar. And of course, it's going to return true or false as a return type, because it's a Boolean return type. It's going to return true or false based on the condition is true or false. So it talks about initialized queue. I'm going to show you this one in my own program. Front and back. Let's talk about very briefly front and back. So front operation returns the first element of the queue. First element of the queue. And the back is going to return the last element of the queue. Okay? So if queue is empty, program has no ability to return anything to you. The front will not be able to return anything to you because it's empty. Back operation returns the last element. If queue is empty, program terminates as well because the back element has nothing to return back to you because it's empty. So, but these two variables will be used to find out what is the last element value and what is the first element value. Then I'll show you the add queue and delete queue. Then we'll talk about constructors and destructors. We have these very similar constructors and destructors in our stack program as well, and how we actually implement this into our program. All right, so I copied and pasted the program. So for our online students, this is the program. And I picked up this program directly from our book. So if you feel more comfortable following the book, this program is in the book. So, but I actually copied and pasted right here, Q demo. So it's a program which basically demonstrates how the queue should be implemented. So this program actually has a stack ADT, abstract data type. Let me see if I can capture it here. Class queue ADT, abstract data type. And we have 1, 2, 3, 4, 5, 6, 7 virtual functions. And these are pure virtual functions because they end with 0. What it means is that these functions or these methods must be implemented at the derived class. So this is our parent class. So this parent class honestly doesn't do anything. This parent class doesn't do anything other than dictating the child class or derived class to implement these methods. Now remind me from last week, why do I need to waste my time and create this parent class? What is the main reason we have this in place? Come on guys, help me. Why do I need to create pure virtual functions in a parent class? What is the value it's going to add it to my coding? Yeah, because as a stack and as a queue, I am absolutely sure these methods must be in place. You must have these methods. You know, like your parents, they will dictate certain things. When you wake up, you must brush your teeth. When you were young, when you were 5, 6 years old, you must take a shower after a soccer game, for example. So they will have certain methods in place. Now, if they don't have those methods in place, you will stink, the hygienic issues, and nobody will like you, and you'll have a miserable day. So that's what we are doing. We are dictating here at the parent level. We are saying, you must have this check for empty. You must have check for full queue. You must have some check for adding a queue or deleting a queue. So you can say, well, I am actually old enough. I can figure it out. Sure, you can do that. But this is a kind of standard we use. This is a protocol we have when we are developing stacks and queues, and some other places as well. So these pure virtual functions allow us to force some few things at the derived level, at the child level. All right, so I'm expecting 1, 2, 3, 4, 5, 6, 7 methods will have the implementations, will have the body underneath. And that's exactly what we do. So before I move forward, just want to highlight here, and this is again from the book. I didn't create these methods. These I just picked up from the book. You can actually follow the book while you're running this program, especially people who are struggling with these concepts. I know some of the students have been sending me messages from online students, especially that you are from Java or some other languages. So I want you to have the book open during when you're running these programs and read those small paragraphs. So here, for example, the function to return the first element of the queue. So the front method is going to return the first element. So first element, whatever the value of the first element is. The back one is going to return, function to return the last element of the queue. So that's the back function, back method. Now this method is function to add queue element to the queue. The next element, if you want to add, it will be added. And the same thing with the function to remove. Most of these methods, just want to, before I move forward, most of these methods, before you go any further and implement them, you want to see what is the return type. Is empty and is queue, just like our stack queue, stack method, when we discuss stack, So we have these Boolean data type is being returned. True or false is being returned. If they're empty or not empty, if they're full or not full. The initialize, add, and delete, they are void functions. They don't return anything back to you. Except there is a add queue. We take an argument. None of the other ones have any arguments. Notice that no arguments are being passed, except the add queue, because you cannot really add new data without passing the data. You ask the user, what data do you want to add? Or you pick up the data from a database, or from a file, or from some other source. Then you have the data in hand. You want to pass that to the add queue method. So that data is being passed. Really simple concept. Really simple concept. This data is being passed. Doesn't matter what type of data it is. Doesn't really matter. Integer, double string, or any other class type. Doesn't really matter, because my program is a template. Based on a template, it can handle it. And I'm not making a duplicate copy from last week. I'm actually passing as an address. So where the data was saved first in the memory, I'm passing the same memory address of that location. So both methods are looking at the same memory location. That's what the reference means. Some people did ask me this question online, and so that's why I'm actually spending extra couple of minutes here. So it means that the original memory address is being passed. Now, for this program, if I remove this one and I make a copy of that data and send a copy, it will work. But it's more useful, especially if you're trying to make it a generic kind of pass, where you do not know what type of data that would be, then it's actually more useful if you pass by reference or pass by address, if you put this ampersand sign symbol there. All right, so that function is going to take going to add something. Now notice that the front and back, they return the data type. The data type return type is type. Now type means whatever the data was stored. We don't know what type of data will be stored, integers or strings or doubles or whatever. Whatever the data type which was stored, I want to return the data type. I want to see the value of the data type. That's why I'm saying this data will be of type. Type means if it was integer, I'm going to return you integer. If it's a double, I'm going to return you double. If I say integer here or string here, then it's not generic enough. To make it more generic, I actually return that type. Okay, just wanted to spend a couple of extra minutes because just wanted to answer some questions from our online students' concerns. Then we look at the private data. So let's look at the private data. Let me see if I can capture most of the screen here. So our private data, we have 1, 2, 3, 4, 5 variables. The last one is our pointer, and it's of this type, which means the type of data I want to add, it will be applicable. And it's going to be an array, or we can make a node based on how we handle it. So I have a variable to count how many pieces of data have been added to the queue. I have a variable to check what's the maximum size. I think I'm not capturing the full screen. So this is for the maximum size. This is for the count. This one is the array list or node list. And these two variables will tell me where exactly I'm pointing in that queue. The queue front is going to point to the first element. Queue rear is going to point to the last element which was added. And this tells me the maximum size. And the brief explanation of each one of these variables are available to you. Okay, so that's our private data type. Before I show you the constructors and destructors, I would like to highlight a couple of things. I'm going to move on and I'm going to show you a couple of things very, very quickly. So we are done with the 2-3 methods in a few seconds. Here's my empty method is empty queue. I think I can capture it here. So check if count equals to 0, return true or false. If the queue is full, return by checking if count equals maximum size, then return true or false. So those are our empty and full. Let's look at the initialization, front and back as well. So we'll be done with those 5 methods. Then we can focus on the other aspects of the program. Here's my initialized queue right there, initialize queue, and I'm actually saying when I'm ready to create a new queue, first ensure my front is 0. If there was some data, clear all the data. Front is queue. Wherever the front was pointing before, make it point towards 0th index of that array. And rear queue is equal to maximum size. So I'm initializing it, initialize queue, and count equals to 0. Count equals to 0. Okay? So that will allow me to initialize it. When I'm checking the front value, the first thing is check if it's empty or not. If it's empty, if I don't check this one, and especially when it comes to node, the link might be pointing towards null. If it's pointing towards null, and if I try to display that value, return that value, I might get a runtime error. In order to avoid that runtime error, I'm checking if it's empty, stop the program or stop processing any further. Don't go to the next line. So this assert function allows you to check if it's not empty, then go to the next line. If it's empty, then you can stop. And all we are doing is list is your array size, or it could be a node, and show me the front value. QFront is a variable which points towards the first element, first element which was added. So list, and if I have a cout command here, cout list, I can actually display it. In this case, I'm returning that one, so it can be displayed in the main function or some other location. And that's exactly what we'll be doing. So I'll be saying cout call this front method. And this front method is going to give me the access to the first element or the front element of the queue. The back is going to do exactly the same thing, but it's going to return you the back element, the rear element. So again, we are checking if its queue is empty. We can't go any further. Otherwise, show us the last element. Right, let's scroll up now. So I'm going to go and discuss with you a couple of constructors and a destructor. So let's talk about the first constructor. So the first constructor, normally we always must have a default constructor. A default constructor is a constructor where at the time of the creation of the object, you did not provide any initial data which was needed for the private variables. So private variables are front and back and count and all those things, maximum size. If that is not provided, then how do you ensure that at least you have some kind of list available? If I'm creating that object, but I did not highlight those areas, how do I ensure at least there's some list? If there's no list, I cannot really process anything. So in this case, just to be on the safe side, we are saying I'm expecting some kind of queue size from you at the time of the creation of the object. However, if you do not provide me the queue size, you forget, you do not provide me the queue size, I'm going to have a default queue size. This is called a default queue size. So if none of the queue size is provided, if you create a queue, let's say size of 10 or size of 50, I'll accept it. I'll take it and I'll create that queue for you. But if you do not provide me the size of the queue, I'm going to create a default size, 100. And that's what we are doing here. And it says if the queue size is less than equal to 0, it means there was no real legitimate queue size. It was equal to 0 or less than 0. And we can say size of the array to hold the value must be positive, some kind of message to the user. So what I'm going to do, I'm going to create an array of the queue of size 100. And I'll say maximum size equals to 100. If you do not provide me the legitimate value, if you provide me negative value or 0, I'm going to create my own default size. If you provide me the correct size, let's say 50, I'm going to take 50 assigned to the maximum queue size. And I'll set my initial variables. I'll say my QFront is equal to 0. My QFront is a variable which is pointing towards the first element of my list. QRear is the maximum size -1. Maximum size is 100, but we only go from 0 to one less, because that's how the indices work, the subscript works. So that's why maximum size is 100 minus 1 will be 99, or if it's 50 minus 1, 49. That's how you can access it. And count, because none of the data has been added, count equals to 0. And here maximum size is 100. So what we are doing is, in this line, we are creating in the memory the size allocated to the list. So if there are 50 or 100 elements, we are creating space for 50 or 100 elements in this line of code. This new keyword, during the runtime, it creates the location to hold the data, space to hold the data. So that's this new keyword is doing. So that will be your one way to use your constructor. Here is another constructor. This constructor will be used or called, or I should not say call. Instructors are always invoked. You cannot call constructors directly. If this constructor is invoked, so expecting some other queue was passed to you. Another queue was passed as an argument. In that case, so maybe our intention was to copy one queue on top of other queue. There was an existing queue, take the data from that queue and copy to another queue. So then we take the maximum size of the other queue, which is coming in as an argument, assign to our local maximum size, do the same thing for the front, do the same thing for our rear, do the same thing for our count, create the list locally for this particular queue, just like what we did with our previous constructor. Once we are done with that, and then just have a simple for loop. Simple for loop is going to run from front all the way to rear, front to rear, and just copy each individual element from the other queue to the local queue. 0th element, first element, second element, third element, all the way to the last element. And this kind of constructor is called copy constructor. Okay, so that's a good question. What is a copy constructor? So this code will be available to you. And if I move something here and there from this code, let's say I put my rear over here, front over there, it should not work. So you should be able to figure it out what the problem with the code is. So if I give you a code for copy constructor, you should be able to figure it out. Okay. And the last thing is here is the destructor. Destructor is self-explanatory, so I'm going to skip that one. However, I'll talk about our operator equal or assignment operator overloading. This is just from last week as well. So this is the signature we need. So we are saying we need to have this keyword operator and assignment operator. It must be passed as a reference. And this is the data type, queue type. And we need some kind of other queue. So we are going to check if one can be assigned to the other one. One queue data can be assigned to the other queue, just like what we did with stack. So what we do here is, I think I can, if I stand here. So what we do here is, if this, what is this means? I asked the same question last week as well. This object which I'm working on, whatever the object is, this object I'm working on, if the current object I'm working on is not equal to the other queue, so this particular queue is not equal to other queue, which means they are not identical. Now this is actually a pointer. This is actually a pointer. It's just like you have a pointer variable pointing towards something. If this pointer is not pointing exactly where the other queue is, if other queue is, let's say right here, if this pointer is pointing here, it means we are pointing exactly in the same place. I don't need to copy anything or make an extra copy for anything. I don't need to check for equality or anything, because I'm actually pointing exactly in the same location. You know, sometimes that does happen as human beings. We are talking about one individual other person is also talking exactly the same individual, but we do not know until after some discussion that we were actually discussing the same person. So here, this pointer allows us to ensure that we are not wasting our resources. So if this is already not equal to other q, then take the maximum size of the other q, put it to the local maximum size, do the same thing with the front, rear, and count. And delete the list, the local list, create a brand new list for the new maximum size, whatever the new maximum size is. And once that's done, take all the data assigned to the local. Now this looks very similar to the previous constructor. It is. It is literally copy and paste from the previous constructor, the one we had looked at. We just basically run from the front all the way to the back and take each element and copy to the local one. Once this has been copied, so I want to ensure I have access to this this pointer, which means that wherever you created this queue or wherever you created this data structure, can you show me where it is? Can you give me the access so I can actually print it or process it or do something with it? So that's what it's doing. It's saying, I'm going to return this pointer to you. I know it's a pointer. It's a pointer return type. So if you have the access to the starting location of this list or this queue, you can access all of them. And it is being returned. Let's take a look here. It is being returned as a queue type. So when I say return asterisk this, it is being returned as queue type. So it's basically the starting address of that queue type of that list. Okay, this is very similar to what we discussed last week as well, but just wanted to spend a couple of extra minutes just to want to make sure that you understand. And then let's talk about add and delete. Then we'll be done. We'll be done with this one. Then I'll talk about project as well. All right, so I want to add a new element in my queue. So this is the new element comes in. New element comes in as a reference of this type, assuming it's an integer. It could be an integer, it could be anything. And then I check if it's already full, then I really cannot do anything. And that's why I say if it's already full, cannot add to a full queue. If it's not full, then what exactly is happening here? Queue rear plus 1 modulus maximum queue size. This is strange kind of code. And I'm trying to assign that to the queue rear in this case. What exactly is happening here? So if for example, if my queue rear is 100 plus 1, that makes it 101. And then I say modulus maximum size is 100. What exactly modulus gives you? Remind me. Remainder. So in this case, if I divide 101 by 100, it's going to give me value of 1. So I'm assigning the value of 1 to the queue rear. And let's see what this message says from the book. So it says use modulus operator to advance queue rear because the array is circular. So you want to do that if your array is circular. If your array is not circular, you don't need to do that. And this is actually further explained in your book. So when you are going through this exercise, I want you to open that page and read that one in your book as well. All right, so what we are trying to do is we are trying to add an element. So my goal was to move my rear to the next location. That's what I was trying to achieve. So then I say count plus plus, we increase the counter. The new element will be added to the queue position, the queue rear position. Remember, we already moved our rear to the next location, previously assuming front and rear, they're pointing towards 0th element. I already moved my rear to the next element, so I can easily add the data to that location. Otherwise, simply say no data can be added. So we'll try to reverse this one in case of delete. If it's empty, if the queue is empty, cannot remove from the empty list. If it's not empty, count minus minus and do something similar. We need to find out what is the value of the front by using a modulus, because assuming we have a circular queue. Okay, so let's actually see how many queues we are creating here. We are creating 2 queues here of integer type. So Q1 and Q2, and I'm trying to add 1, 2, 3, 4, 5, 6 elements into my queue, and I'm deleting one of them in the process. I'm deleting this one. Then I'm just showing you that you can actually add data in various ways. You can add data by having some kind of calculations here. You can also data by calling another function. This could be a function call here. You can actually call a function. The function can read the data, return some kind of value back to you, and that's how the value can be added to the queue. So it actually allows you to be more flexible how the data should be added. So once the data has been added, then we are calling a test copy constructor, and I'll talk about that particular method here. That's a local method. It's not part of our class structure. It's a local method, so I'll show you that one in a minute. Then I'm checking if, I'm assigning Q1 to Q2. So everything was added in Q1. All the data was added in Q1. So whatever the data we have in Q1, assign to Q2, make a duplicate copy, and then show the data in Q1. So once the data is displayed, show the data in Q1, then display the data in Q2 right there for the camera. So just like what we did in Q1, show the data in Q2 as well. And then that's it. Let's test it. Let's test it. So I'm going to run this one, and let's see if we can understand it. Okay, so here are the results. My x is equal to 4, my y is equal to 5. As you can see, x equals to 4, y equals to 5. So what's the first element adding? I'm adding 4, right? Adding 4, because that's the value of x. But I don't see 4 here, so we'll figure it out. Then I'm adding y, which is 5. I'm adding 5. Then what is the value of the front here? What is the value of front?
4.
So value of front is 4, because front is a variable which stays with the first node or first element. So 4 is being assigned here, and then I'm saying delete that 4. Delete the first element. Delete the first element, because that's the first one will be processed. Then I add 9, because x was assigned 4. 4 plus 5 is 9, so 9 is added. Then I add 16, 16 is added. Then I add another 4, which is right there. Then I say y, which is 5, minus 3. 2 is added there. So 4 is missing because we deleted 4 right there. We delete the front element. So 4 was deleted, that's why it's not there. Then we make a copy of Q1 to Q2, and the copy is being displayed successfully. So let's take a look at the last test copy constructor method. So test copy constructor is right here. So in test copy constructor, we are passing the other queue. Other queue is, you have 2 queues, stack 1 and Q1 and Q2. So other queue is being passed. So you're checking if the incoming queue, if it's not empty, other queue is not empty, front element of the other queue, and you're just basically displaying the front, and you're deleting the front element. So basically it's telling you that you can do a lot of manipulation locally as well. So you can actually do some local manipulation as well if it's necessary. Okay, so that's our Q discussion. This was a really simple lecture. It was simple because we talked about stacks. It's very similar to stacks as well. I'm going to talk about our assignment 3, then we'll be all done. Assignment number 3 is from page 1263. Let me open up my book. All right, so assignment number 3 is from page 1263 from your book, from chapter 17, number 14. And it might not be that clear on the camera, but you can actually see in your book. Write the definition of the function move nth front that takes as a parameter a positive integer n. The function moves the nth element of the queue to the front. The order of the remaining element remains unchanged, for example. So just like I have a function here, test copy constructor, maybe you can create either a local method or method within your class so you can actually move an element from your queue and display that second queue with a different order. What it means is, let's say this is your Q1. This is Q1. Has 1, 2, 3, 4, 5, 6 elements. And I want to move the nth position element. So 1, 2, 3. I want to move this one. I want to move this one, in this case, value 34. So you will ask the user, what position do you want to move? What element position do you want to move? User says, I want to move the 34, the third position or 34 value. So after the call of the function move nth front, that's the name of your method. That's the name of your method. You take 34, put it in the front, and rearrange the order 5, 11, continue with 67, 43, 55. And that's it. That's it. So you will have a queue. You will fill that queue. You can ask the queue element from the user to just fill that queue. Once the queue has been filled, ask the user which position must be made. Moved, and don't assume it's going to be the third position. Ask the user what position you want to move. So the position will be given by the user once it's moved. Now, I actually recommend that you have Q1 and Q2. So you still have the original queue, and at the end of the program, show me the original queue and show me the queue number 2, which has the new organization of the data. Data is reorganized. Okay? So that will be our project number 3, assignment number 3. This will be due on Sunday. Also, once again, for our online students and for our on-campus students, next week we'll be taking our exam based on chapter 16 and 17. The following week we'll be starting chapter 18. Chapter 18 will be a completely different discussion. We'll be discussing searching, sorting, and different kind of algorithms, I'll be activate that our week on our Moodle site as well. And that's all. That's all we have for today. Thank you very much.